Okay, we're live. Sweet. Um, so yeah, so I wanted to call this. It looks like one more person might be coming. Okay, cool. Well, so we'll wait for him. Wait for him. No, I guess we can get started. He might be just listening in. Cool. So basically, TLDR is we might be doing. So I don't know, Pam. Or Anna, are you on the which sub team are you on? You're with the chat with your code base sub team, right?
Yeah, that's right.
Um, so I don't know if you guys like have any updates, but TLDR is like as far as the overall concept of indexing code, right? We just got freshly done with the imports context. Pam and Elwin know that pretty well, where that involved like a lot of static analysis. And um, what I was thinking is how can we condense as much logic as possible when it comes to static analysis in a way that we're not duplicating efforts across all of these teams. And part of that involves like basically creating a strategy because as far as chat with your code base, I don't know what like the initial what is it? MVC is going to be for that, but um, as far as the knowledge graph, we're going to be doing a lot of static analysis, like looking at function calls, looking at imports of files and whatnot, taking that data and indexing it into a graph structure, right? Um, I talked with Shakar a little bit, um, and I don't know if you guys have talked to him on the chat with your sub base, with chat with your code based sub team, but he was mentioning that there's like multiple strategies for actually chunking embeddings data, right? There's like chunking the entire document, and like getting a summarization maybe via the LLM of the different things in the document and chunking that as one embedding. Then there's like the chunking strategy that other vendors use, which is parsing the actual function definitions and stuff like that. And that's one strategy. And then I forget the other strategy. You might have to ask him on that. So I'm specifically alluding to the second strategy, where I don't know if you guys have chosen that yet, but um, if we go with any type of static analysis, my main thing that I think would be really beneficial is we all get together and collaborate on one parser essentially that can handle um, a majority of the static analysis in one code base, if that makes sense. And then we share logic where we can. So that's one thread. And then specifically more on the language server side, but Pam, you're very familiar with the language server now, so like you're basically on the team at this point. But what I was saying is the other thread is like local changes. So that's one thing that we're trying to figure out in the um, knowledge graph is how to essentially um, handle the case where the user, simple case, which is actually a lot of what we do. The user changes 20 files in their code base, and any query that goes to the server is just automatically stale, right? So really, if all the data is on the server and you're not actually syncing with the server, or creating the embeddings in this case locally, um, then the most you can do in your editor is just ask about existing code bases and like the main branch and whatever branches that have been indexed, and that's pretty much it, right? Um, so there's really two threads. The first one is I think the more important one, which is like if you got asked first if you guys have thought about, your chunking strategies as far as that, or any parsing that you plan on doing, where you're thinking you might want to do the parsing. I can kind of give you a lowdown of what we're thinking on the knowledge graph side so far. And then the second thing is if you guys have started thinking about like local changes, so we can all kind of combine efforts in that way. Um,
Uh,
but
yeah, I guess like to start on the discussion, Tian and I haven't really talked about like how we're going to chunk the embeddings, but I
Mhm.
don't think we're going to need as much detail as knowledge graph because we'd want we for example, if we want to chunk it by function, that might not be actually enough information to get for a um that might not be actually enough context if you ask like if you use it as additional context for your question.
Mhm.
So right now, obviously Tian and I will need to speak about this, but right now I think we should probably be chunking by class. um
That makes sense.
I think for Ruby, and then for TypeScript and Python there's going to be classes in there as well, but if I'm not mistaken, TypeScript and Python, you can also like define just functions. So
Hmm.
I think like class and like first level functions, like basically anything that's at the top of the
Yeah. Yeah.
Yeah, so one question here. I think there are two context storage. So one is embedding abstract layer, so which I think the global search team has already been working on. And another one is knowledge graph. So I think for this phase, we are mainly using the embedding abstract layer, right? So these two storage, so is there any logic that can be shared by these two storage?
uh is I think this is just for parsing, right? Like the
Yeah,
Parsing. Yeah.
parser, and I'm
Yeah.
assuming it's
parsing.
going to be stateless.
Yeah, the parser would be stateless. Like it would be, what I'm thinking is basically a library. Like we create a library somewhere
Yeah.
and it's versioned. So it's like properly versioned. We have a schema that will come back always, depending on the version, right? So for instance, you parse a file, you give it a file string. Like this is in essence what the library conceptually would be. You give it a file string as an argument. You give it the language as an argument, and then you ask for whatever you're looking for. I'm looking for class definitions, right? As an example. And it'll give you back a structured response of all the class definitions. And the library is responsible for any static analysis, right? So, and sometimes it can get actually complex, right? So like if you're in a TypeScript file, everyone knows this. You might know this as well, Pam, based on when we were doing the imports. But like if someone renames an identifier, right, or something, right, you can do something like you rename a type as something. You want to usually actually get the source identifier. So you can, for instance, the knowledge graph can grab that identifier and find the identifier in the right file. If you use the aliased identifier, then it will give you nothing back, right? I don't know if that would be as useful maybe in the embeddings world, but yeah, there's just like a lot of logic that we can condense into one library. Um, so that's why I
Yeah.
was
So
asking like, where you're thinking of doing the parsing itself. Like, do we have you guys thought about doing it on the client yet? This might be like also an Anna question. Like,
yeah.
do you want to be doing the parsing on the client? Is it only going to be on the server? If it's going to be on the server, is it going to be on Gateway? Is it going to be on Rails? That's the question. I don't know. You get him smiling, so I'll.
So for the so the team, by the way, is called now code base as chat context because it covers like what actually needs to be done.
Yeah,
The code base is an additional context to the chat requests.
yeah.
So we're considering like any local changes out of scope. So we're definitely not doing that locally. I'm not yet sure. So Maddie's working on adding support for chunking on for the code embeddings. So for embeddings, I mean, as like in the AI, what's it called again? Like the con AI context abstraction layer. So she's working on adding chunking support for that one. That's going to be on Rails.
Mhm.
I think what we're actually going to do, because I'm there's nothing like Ruby's not really good for this, so we'll probably need to call an API to do the
Yeah.
chunking.
Yeah,
Yeah. So
Ruby is probably out of the question. There's based on my research, which is like a year of research now, there's like no tree sitter support in
Yeah.
Ruby, as far as I've seen. The main two things the targets that I have at least is Go and Rust. There are some pros and cons with each. Um, and if you're doing it in Python, for instance, I don't theoretically see why not you could use either of the two. I don't know about Go so much as I know Rust is like, for instance, the Anthropic tokenizer is written in Rust, and they basically called Rust via FFI in Python, as far as I'm aware.
Mm.
I'm not sure about Go, but um, yeah, that's what we're looking at least on the knowledge graph side. Um, which
so
one of the two?
is this parser will be fitting to this framework that global search team is building? So I think they've already built something. I've sent the link in the chat. So they are, I think they are using this I think engine to parsing a file and get the embeddings and store that in Elasticsearch, for example. So they make it kind of extensible, so we can make our own adapters. They call that, I think it's adapters. So for example, we can use TreeSitter to adapt those files and create a new embeddings instead of, I think for now it's default one. It's just using the length, the word length, or each document is kind of fixed length. I think that is very basic version of the, I think that is the embedding chunking logic. But I think, do we need to fit this parser to this framework? So we need to consider what the logic there in the Rubies.
So
Gotcha.
Yeah,
so I'm looking at that framework. The adapter is for the basically
yeah,
where code is going to be, where the embeddings is going to be stored. So it's either Elasticsearch,
yeah,
um, Postgres, and there's something else. But in terms of like parsing, like sitter parsing, I think that's different. It's not. I'm not sure that's related to the adapter. So actually,
yeah.
here's
So
one.
yeah,
This is the this is an update from Maddie about basically adding the chunker into that framework. So, but the chunker itself is, it's still like we're still going to need to define a class in Ruby, but I
yeah,
think what we can do on our side is either have like introduce a chunker class in Rails that calls an API to this one parser that will do the chunking, or actually, since the embeddings is going to be the actual generation of embeddings is on the AI gateway, so it's in Python. Maybe we can actually as well speak to Maddie to do the chunking on the AI gateway itself, like call the chunking
yeah,
from AI
yeah.
gateway instead of Rails.
Yeah, that's what I'm saying. Because it seems like they are trying to build a system which is extensible, so that different teams can build their own chunkers.
Yeah.
So for example, in our team, we want to maybe use TreeSitter, and how to implement that API is depend on us, depend on the scenario. Yeah, and I think that the final storage in this case is always embeddings. For example, in this case, it's Elasticsearch or Postgres, but it's storing the embeddings. I think that's different from the knowledge graph, but maybe there are some similar logic there. For example, the first part is parsing, which can be used to parse out the file from the file to embeddings, and in knowledge graph, it's parsing from the file to maybe different components or
Yeah,
elements.
Yeah.
there's gonna
Yeah,
be that's what I'm saying. There would be
yeah,
a lot of logic overlap.
yeah,
And also we need to be on the client as well. So that's why I'm trying to think of is there a solution that
Yeah.
we can write once and it works everywhere. That's the main thing that I'm thinking. Just like one static analysis library that you write it once, it can just work everywhere.
Yeah.
And it might be that, so on the knowledge graph side, based on my talks with Jan and Vitaly, it might be that we write because, for instance, let's say language server needs to use this logic. I did just find that based on what I just saw, you can't compile Go code, Go tree sitter code into Wasm based on what I saw. And the reason why is it uses CGO under the hood. So it takes the tree sitter C dependencies and compiles it. And when you compile Go, um, when you compile Go with Wasm, it actually just takes the raw Go code itself and converts that into Wasm bytecode, right? But you can't take that layer from C to Go to Wasm. Based on what I saw, maybe I have to keep digging into it, see if we could do it. Because if we can write in Go, then we can write everything basically as far as like one shared library and then just chunk out different parts of the library. So you have like one AST thing. But it may be that I don't like that's the debate. That's not the debate, but that's the research that needs to be done is what runtime is the best for that. And then we might, I don't know, have to embed, for instance, Rust into Go for like on the knowledge graph side, any of the large volume that it'll be handling. So like anytime it needs to talk to Gitaly and whatnot. So I don't know what you guys have found as far as like where you want to be doing the parsing, but I figured like it'd be better to start sooner than later just to keep in contact and then um, start thinking of ways that we can kind of have one shared library because I think we'll be able to move very fast. Let's say, for instance, you guys are want to add support for, I don't know, a new language, like you're adding support for C++ or something, right? Um, and then we're also doing the same thing. If we have like an already existing foundation of like an API essentially that where we can just say, hey, give me all the C++ classes and it just handles it all for us. And all we have to do is on the knowledge graph side is worry about resolution or connecting nodes. Because let's say you guys already built that logic. Um, I think it would be really beneficial to like a bunch of different teams. So
Yeah.
that's
Yeah.
the main.
No, I agree with that one. We haven't looked at it though, so your research on Go and Rust is actually useful. I was wondering if Tian, you've had a look if it's, or Angela, if you know it, if it's reasonable slash possible to do it in Python.
Um, I'm not sure we want to do it in Python, just because a lot of these are going to be probably very high throughput. Um, so when it comes to the actual computation, I would do it in something that's like not garbage collect. Well, Go is garbage collected, but something that where you can actually maximize usage of threads and performance. Like Go gets compiled to machine code, right? Versus Python is like it's got a JIT, it's got an interpreter. So I think I don't, as far as I mean, you could always create a Python binary, right? And do the logic in Python. But if you're gonna set it in front of a high throughput service, I'm not sure we want to put Python as the bet there. I would do something a little bit more lower level like Go or where you can actually control what you're using in memory and have pointers instead of just objects or and everything like that. So um,
I imagine Python would have the same challenges with compiling to WASM and having tree sitter stuff not compiling to WASM as well.
yeah. Um,
What do you think, Tian? Because you've had more context around the AST than me on this one. What do you think?
I was more thinking about from the perspective of searching side. So for example, the user asks a question, and for the code, there are local code and there are remote code. For the remote code, I think we've already have a completed embeddings or knowledge graphs. We can get the context easily from there. I think the other part is the local changes. So some part of code is not a remote. So how can we get a context from there? And I think in this phase, we are not considering the local part. So we are basically building I think a parser for the remote code. So what we are trying to do is trying to make the parser also work for the local code, right? So that means the parser has to be some kind of APIs. It's not a binary in the client. So that is what I'm envisioning. But then we need to have efficient way to get the code difference from the local between the local and the remote. So if that's possible, then I think we can get a complete context combining the local and the remote. So yeah, so that is what I'm thinking. For the local changes, we can just the input will be a very small code difference, and for the remote, we have I think the cron job to building or update the
Yeah.
embeddings or knowledge graph every day or every 1 hour, like this. But yeah, so that is what I'm envisioning. So do you see any drawbacks or limitations here?
No, I think we're on the same page with that,
Yeah.
Angela, right? Like I'm more wondering around whether you have any thoughts on the Go versus Rust, like what kind of language would be developing in.
Yeah. So from my investigation, I think I did some experiment using tree previously. But when I was experimenting with that, I think that is written in C, right? So I'm just using C to parsing the files. So I'm thinking, is there why don't we just try C? Because I think tree is written in C and the paper is written in C as well, right?
Yeah, I mean, I think
Yeah.
their code base, based on what I saw, like their code base, they might be migrating to Rust.
Oh,
In the main tree sitter like organization, but it might still, the core engine might still be C. So I mean, we could consider also C. Like, I mean,
yeah.
it's not
Yeah.
I guess out of the question, but yeah, there's like different drawbacks for each because Rust has first class WASM support. So you'd be able to um I can show you guys actually a small demo um if you want to see. Um Give me a second. Can you guys see my screen? Question mark.
Yep.
Yeah.
Okay, so let me pull up. So if I open this up, so like a breakdown of how this works is I'll go to the actual code here. This is not it. AST, or sorry, build AST. So just to show you guys, make this a little bit bigger. This is Rust, right? And this code here is just doing a basic parse, right? So it's just parsing the tree and getting the tree. And it's using the tree sitter dependency. And it's also using all the different tree sitter languages. So that's one thing about tree sitter is it's got first class support for Rust as far as I've seen. So you can just see it like we're just using tree sitter Zig as an example. We use the language, and then of course like you can use any of the APIs. Like you can go in here and access any of the APIs that you want to use. And so it's just doing some basic stuff, and then it does some basic parsing here, and then that's for each language, and then it can you can basically traverse the node there essentially, and so that's what I'm kind of showing here. Like it's showing the AST node, etc. And what this is doing is in the make file, you have to download believe it or not, like you were saying, Tian, you have to download one of the C compilers, but you set the Clang option here for actually compiling the C code and translating that C code to WASM. So, and then we set the target to WASM. And so what happens here is when I build this, if I do npm run build, I think, it actually transpiles this into a WASM. And on the JavaScript side, just to show you, if we go to the web here and we go to generated, you can see we have a full TypeScript types. So we have get AST, get whatever. So these are exported straight from Rust. This is the JavaScript WASM shim. And then this is the actual WASM binary. And it contains, like if I just show you in the folder, reveal in Finder. Why is my Finder not showing up? Okay. It's got all of the tree setter dependencies literally within this WASM file. And so what that means is I didn't actually wire it up to the UI. But you can take any sample code here and, oh, let me actually start the server. Sorry. Run start. Oops, I can't see because the Zoom meeting is there it is. PM start. And if I go here and now open it and I'll show you guys. So you can see on the right here, these are all the different languages and the AST being parsed via WASM from Rust. So if you guys throw me any Zig code, for instance, or like Python, if you write Python as an example, I don't remember how to write Python, but I think it's like, if you define a function, right, return, I don't know, 1 or something, right? So if I go over here, you're going to see probably errors for a bunch of these languages, but Python was successfully parsed here. So you can see the AST. We've got like the identifier, parameters, block, return statement, integer, in this case. And this is done via Rust bytecode. It's not like WASM. So in the current language server project, we have WASM binaries, and then we have JS bindings, which talk to those WASM binaries for every language. This is just one WASM binary written in Rust, and the traversal is done in Rust. I'm trying to see if I can do the exact same thing in Go, because it might be better that we do Go because we have more engineers who are experienced with Go than Rust, and it might be better to just like share a bunch of logic via Go. But this is if we want to even just call this code directly. It may be better that, and this is what I was discussing with Elwin, it may be better that we write it all in Go and we accept that it's only a binary form, and any shared logic that we want to do on the client, we just call this binary via the language server and talk to the binary back and forth for parsing the file and whatnot, if that makes sense. So yeah, just wanted to show you guys that. I don't know if this makes sense or if you guys have questions.
Yeah, I'm curious about the concern between like having this WASM. Does that mean, because you said it's going to be if it's in Go and the binary is going to be called from the language server, but the language server is also running locally, right? So what's the difference between this WASM? Is it going to be called from like the VS Code extension, like the VS Code extension repository?
Yeah, if it's WASM, we can call this call the code in the language server itself. We don't need to spin up a binary or anything. It's most likely that if we choose Go, we're going to have to spin up another binary on the language server side to do this parsing, if that makes sense.
So if it's WASM, we get nice type-safe APIs, whereas if it's a binary, we're going to have to do like standard out message passing and like serialize everything, and it just won't be quite as nice ergonomics.
Yep. Anna, what were you going to say?
Elwin just answered my question.
Oh, okay.
I see.
Yeah, so that's the major trade-offs is like what is first we got to figure out like that's why I was hoping John would join, because for local changes, do we want to just replicate the entire thing, like a lot of the code paths locally? Like for instance, when you go to chunk, let's say you do want to do embeddings. I'm putting it in the embeddings world, but this is the same thing applies to knowledge graph. Let's say we do want to handle local changes and store users embeddings locally, right? So like the user changes 20 files, they're completely out of date with the server, but they still want to run queries on their code base, right? So you still need to do embeddings locally on that. And assuming we're not syncing with the server, or if we are, it's like, let's just assume we're not syncing with the server for now. And you want to replicate the embeddings parsing locally. It's do we, like we said, do we spin up a binary or do we or do we call that code? Do we do this parsing and all that logic in the actual language server logic itself is the question. One of the benefits of doing it in a Go binary though is, I don't know if it wouldn't really apply to embeddings, but for knowledge graph, like we have to connect a lot of things. So if we write logic like, oh, this file imports another file, right? Like this Python class imports another Python class that's in the code base. We would just have to do shims for actually reading the files. So the file on the language server side, the file reader would be like, the actual file system, but on the server, it would be like Gitaly, right? So, hey, we need this file. Let's call Gitaly or let's call the local file system, depending on the operating system it's running in. I'm not sure it would really apply too much to bendings because I think you're only handling one document. You're not really chunking and embedding like across documents from what I've seen so far. But I don't know if you guys do that, you might want to do that. So yeah, hopefully this makes sense. But yeah, yeah, it's definitely a lot to drop on you guys. So that's why I figured start asking now.
Yeah, no, I haven't looked at like the advantages of Rust versus Go in terms of like calling it from the server side. I don't think there's really much of a difference. I think the main concern would just be knowledge about the language. And I know that there's already some engineers that know Rust in GitLab, but there's more that knows Go. So that's a consideration.
Yep.
I'll have to look about. I don't think it matters like what kind of like the API that we can put on top of it. I think it's the same Rust versus Go. So I think it's more of I think the bigger concern is the how this is going to be used on the local side.
Yeah, that's the part of the question mark for me, and why I wanted to pick everybody's brain is like if you guys start thinking about that and whatnot, because that's basically what I'm kind of tasked with on the knowledge graph side. So which might apply to also embeddings. So handling local changes is kind of a question mark right now. For the knowledge graph side, it's like kind of complex because you like if you have a tree of nodes essentially, right? Like a real graph where everything's pointing to each other and you invalidate one file, your graph could be entirely broken and your query result might just be completely way off from the server to the to the local client, right? And like we talked about like syncing the graph, but we ended up just thinking maybe it might be better to just run a whole graph locally. And then if the user is on the main branch and they haven't changed any files, run a server query. So yeah, it's definitely interesting stuff. You're gonna say something, Anna?
Yeah, I was going to say, I do think, of course, it makes sense to think about this because we will eventually want to be able to, ask questions against the whole code base, including local changes. But I was going to ask a really stupid question, which is, so for our side, which is like, asking questions with your code base as context, in the short term. So yeah, long term, we'd want to be able to have embeddings for your local changes. But in the short term, what would it look like to like ask questions using like the main branch as like with embeddings for the main branch, and then just like throw the like git changes in as additional context.
Like you throw like there's search result and then a diff on top of that, you're saying?
Yeah, like would that make any
Probably
sense at all?
it could work. That's what I was thinking. That's what I was thinking would be nice for the knowledge graph, but it wouldn't work for the knowledge graph because um I think they're a little bit more isolated query results.
Yeah. I feel like that could work in some situations, but not all situations. Like in some situations, that diff might perfectly resolve the differences, but then in others, you might end up with a set of search results from embeddings that are not at all relevant anymore, plus a diff, and that could then lead to worse results because it's got a bunch of context that's not relevant. But I don't know how you would test that or measure it.
We can let the AI model take care of it.
Well, that's one interesting thing. Sorry, Pam. I just wanted to add to that. Like, other vendors, I listened to a podcast and they explained that what they do is they maintain a file hash. So every file has their own hash based on the content. And then on top of that, they combine that hash with the file path and the directory. And once it hits a certain number of files changed, they just rerun the indexing for those files and store them on the server. So it's always syncing with the server, which is kind of crazy. Like you could go and check out a new repo and see it's syncing, and then it finishes syncing, and that means they're doing that for anytime someone opens the editor. So the volume that they're handling is probably insane, but yeah, that's one of the strategies that that one of them is doing. And the other one that I know that's doing a different strategy is they do everything locally for the most part. So they parse everything locally, they create the embeddings and store the embeddings locally and store the embedding changes locally. So
So they will
Okay,
have to.
another stupid question. Like, what does that look like as far as the amount of like storage space that takes and like how much computation that requires?
And the networking side
a
as well. If you're syncing everything on a bunch of key presses, then that's going to be thrashing a lot of network.
Yeah. So from the description from Angelo, it seems like they have to keep number of users copy of the contact, right? Because every user's contact is different. So yeah, it seems like there are, yeah, the storage cost can be huge.
yeah.
I have a question. So isn't local get diff already an additional context for chat? Or did I like misunderstand that?
Yeah,
It
yeah,
is.
but it's just taking get a diff of your current changes. Were you gonna say, Ellen?
Yeah, just the same. It's just a string of the git diff.
Right.
Yeah. So yeah, it's definitely a tough problem. Like it's very much a tough problem. Um, but
I think what Tian just said is maybe the thing that is kind of the forefront of my mind is that every user has a different set of context. And so if we're trying to have a single embeddings layer on the server and keep that up to date, it's going to become, it just doesn't scale like for every single user. And to me, then the implication is that we should be doing that on the client or as much of that on the client as possible,
right.
which I'm not. I mean, I don't know too much about the current context framework, but I don't think it's set up around that at all.
Yeah.
And I don't really know how to bring those two things into alignment, which is, yeah, I'm just a little worried that we're not considering the local context now as part of the scope, and that might lead to a bit of a dead end in the future.
Yeah.
Because to me, the local context is A, the most important bit for an engineer using the product, and B, the most complicated bit for us to build.
Yeah.
Yeah.
I would
And
agree.
the storage stored in client versus the storage stored in the server. It seems like in these two scenarios, the query can be very different. I haven't think much about how the query gonna be if the context in the server, in the client. So, so for example, in the server, when we request a question from the customer, we just analyze the question and then uh, and building the context from the question, and then we can send the prompt to large language model and get a response. So what gonna be the query scenario looks like if the context in the client? Do we need to first calculate the context in the client and then send the for example the payload to the backend?
I would imagine so, yeah. I would
Yeah,
imagine the client would be resolving all of that and then attaching it with the prompts.
Mm.
yeah, yeah. And it seems like very different from what the global search team is already building. They're building the searching in the server side. So if we are gonna store the context in client, then we maybe need to build a different framework, not the Rails one.
Yeah.
Yeah,
That's the thing is like I think
yeah,
Owen's right in the sense that like that's why I've been so evangelical on ensuring that we can have local changes prioritized for the knowledge graph because that's what like just like you were saying, Owen, like it's the number one use case is I'm working with the code that I'm working with right now. And if it gets
yeah,
stale, it becomes pointless. So and the editor is definitely a different experience.
yeah,
Um, and that's why
yeah,
that's why it's even more important that I was saying the parsing is we pick like the right thing for the parsing because it has to work for the client and it also should work for the server, right?
mm.
Um, so yeah.
Yeah. That's definitely need some discussion with a global search team. It seems like the framework they're building is not um from the client side, and it has some limitations here. So we can see, are they gonna extend their the capability of this framework, or we have to build a brand new one?
I think there's still some value in the server side stored
Yeah,
embeddings, right? Because that can be the base. You can replicate that locally and then build on top of it. Because we wouldn't want to like rebuild your embedding storage every time like somebody
Exactly, yeah.
new project.
So for embeddings, like it might be that you want to follow the strategy that you have a hash of all the files, like I said, where you have do your tree of files and you check which ones have changed compared to the main, and then you take the embeddings and you create new embeddings, store those locally for the changed files. Um, and run a search probably on the local embeddings and the server simultaneously, then re-rank the results probably is my guess.
Yeah, but the thing is, for example, I change the file, delete the file. So the embedding is in the remote, but in local, there's no such file. So if I do a search in the remote and then do a search in client, maybe there are some conflict components.
Yeah,
in
so
that
you would
case,
you would delete the file. So you would make sure like if it hits a result in the server and you get it back a result for the deleted file, you just don't include that file as part of your context to the chat request. Does that
yeah,
make
So the ranker would also, it would filter and rank, and the ranker would become quite a lot more complex then potentially, right? Dealing with those.
Yeah, so you would just remove that's how I would build it at least is like you would try to cache as much as take from the cache as much as you can, which is the main branch. And then anything you change locally, you invalidate. So if I deleted a file, then anything that comes back from the API on the server, I make sure I do not include if it's the same file, right?
So sorry, is that where the file hash comes from? So if the server returns a result that's related to a file hash and your local file hash is different, then that result is just discarded.
Yes.
Gotcha.
It's harder for the knowledge graph to do that though, because yours is just like basically key value storage because you can't have like multiple files and different relationships, but the knowledge graph has tons of different relationships. So you have to like traverse all of those relationships to create a new state of the graph based on your changes at the time. So in some sense, it's definitely an easier problem for you guys, but also still really hard. So yeah.
Also, silly question, how big are these embeddings? Could we do a sync the other way and sync the full server embeddings to the client to use as a baseline, or are they like massive?
I don't know. Like you mean in terms of like per project?
Yeah, so if you clone a repo, you start by syncing the pre-calculated embeddings from the server, and then from that point on, maintaining them on the client.
I don't know how big.
we haven't do the experiment, but I think the global search team has to experiment on. I think they did on the AI gateway repo, but we can have a sync with them on Friday.
Yeah, that'd be good. That's a good question. Can we write that down actually?
I was just
Embedding
thinking
side,
we've talked about syncing client state to the server, and could we go the other way? But I don't know if it's feasible.
client state, or are you saying server state to the client or client state to the server?
Well, I know we've talked about like when you change files locally, sending a diff of that file up to the server so that it can recalculate embeddings based on the local changes. But yeah, I was just wondering if you could go the other way as well.
Like the server comes back with, can you explain what you mean?
So I was thinking when you first start the project, it would grab the current embedding state from the server to the client, and then that's the baseline. And then as you make changes, it would be modifying those embeddings rather than redoing
Yeah,
them all from scratch.
that's essentially what I was meaning is essentially like anytime you make a change, then that hash for that path is invalidated.
Mhm. Gotcha.
Yeah.
I think the problem there is we don't have search support on, like right now we'd have to build that. The searching embeddings, as opposed to searching out on the server, which the AI context abstraction layer already provides.
Yeah.
It's combined with the Zoct and like the advanced and basic searches.
Maybe I was misunderstanding what you're saying, Angela, but were you saying we needed to do that anyway? Like we need to run the search locally anyway with the changed files? Were you saying like we would send those changed files to the server and then run it there?
Well, that's the $1 million question is which strategy is best and which one can GitLab handle, right? Because certain vendors, I'm trying to refrain from names, but I know of certain vendors, they do the syncing on everything's on the server essentially, and the client is just maintaining its current state. And anytime you change anything, it just resyncs with the server after a certain amount of changes. But they can handle that because they can just horizontally scale as much as they want, right? That's a little bit harder for us. And I think they do duplicate based on the user and like what the user, if the file hash is the exact same as someone else who's using the exact same project, they actually just store the hash on the server, universal hash of that. So that's something that you guys might want to explore is like if you change the file locally, it may be that you do store that on the server and send it to the server and it gets stored there, but you only try to store it once universally, right? Because I think there's like I was talking about this with Elwin. There's like the way a Git works, right? Is you have a certain content of of the the string itself, and when you add a header, it should create a reproducible hash string, right? Is that the case or no?
I think so.
Because if that's the case, then you can theoretically deduplicate that across many different um, uh, people's branches and changes and whatnot. Does that make sense, Anna? So there's two strategies, like send the data from the client to the server, and everything happens on the server as far as calculating the embeddings and storing it. Or the other approach is the embeddings get sent to the client, the initial embeddings, and the client does a search on the server for the query and a search locally on the local vector store. So those are I think the two options.
And would the latter mean that we need to port over the search stuff anyway?
Yeah, the latter would mean you'd have to do local vector search. Yes.
I imagine this is a better question when like Maddie or someone is involved, but do we have a sense for like the level of difficulty of being able to sort of package that up and make it something we could run locally?
Well, that's what I was saying, and if that's what I'm saying, it might be worth exploring just writing it in Go and calling this binary from the language server and just having it in Go, because then we can write the knowledge graph stuff in that binary. We can write all of the like you said, like local vector storage. Because if you're using Golang, we can write some really high performance software that's like optimized for vector search locally, right? Which could probably share some logic that's already existing from Elasticsearch, just with the downside that we have to manage this binary on the language server side. So that's part of the gotchas there. Yeah.
Yeah.
So yeah, it's food for thought. I think we're actually at time, right? So yeah, let me know what you guys think if you start playing around with it. I'm gonna post my findings on the issue or start breaking it down and whatnot. And then we can kind of strategize from there. But if you guys think that it's worth at least having one parser, I can go ahead and create like an issue for that, and we can just work from there and try to condense that research into something that's actionable, and then we can probably just end up creating a project for it. And then like maybe on the Python side, if you guys decide to do the chunking on the Python side, you can just import the library. It just depends on what runtime we choose to and how easy it's going to be to use both.
Yeah, no, I
But
think it makes sense for the long term to have just one library for parsing. And I don't think any decisions around local searching / parsing should block like the server side, because we'd still need that server side in the like embeddings anyway.
Yep.
Yeah,
Yeah, for
the questions
sure.
around that query.
But I think it is important that, like Ellen said, we design for both in mind.
Yeah.
Because we don't want to pigeonhole ourselves into only server and then we can't do anything locally.
I think one consideration as well is if we are going ahead with server-side search and embeddings and stuff, if we do later have local and combine server and local results, like Angela was saying, and then discarding the stale ones, we would want the search to be fairly consistent in how it works. It would be kind of, if we had like one solution on the server that's returning a certain set of results and then a subtly different one on the client, that could become a lot more difficult to reconcile those two sets of results.
Yeah. Yeah.
Easy peasy.
I made, by the way, I made a note of what you said here, Anne, about like using git diffs to determine whether something's changed. Because I think that might be all what embeddings need, as opposed to like doing a hash. I mean, like doing like a hash of the files.
Cool.
Yep. Yeah. Another way you could also do it is send a git diff, and do that resolution on the server side too, potentially. So
I
like,
worry about that in terms of like how big it is going to be.
yeah, that's the thing. And that's why you would write in something like Go. Like you'd send, if you send the giant git diff up, like it should be able to parse that diff and extract the files and talk to Gitly and do all that stuff. But that might be a lot, like on the server. Yeah, so it's definitely a very hard problem. It's not a simple API endpoint for sure. It's like, if anything, this is a distributed systems problem for sure. So, but yeah, I appreciate everybody's input. Hopefully I helped you guys too. I don't know if I did. I probably stressed you out more than anything. So, yeah, let me know what you guys think. I can create something so we can like continue to async discuss it. And if you guys want, I can also set up something like recurring, maybe every 2 weeks or something. So we can stay in touch as teams, but we can also see what people say on Friday and have everybody watch the recording of this. If that sounds good. So
Cool.
cool.
Thanks for setting
Cool.
it up.
Thanks, Angela.
Thank you.
Thanks everybody.
That is